Welcome to Baker Concrete Construction Target Feedback Training. My name is Dan Dorfmiller and I will be your instructor. In this training session, we'll review multiplication, division, area measurements, cubic measurements, finding areas of common shapes, and what is target and feedback, meaning what are man-hours and the relationship to units, how to find man-hours per areas of work, and how to calculate man-hours performed on a given area of work. Multiplication is taking a number times another number. An example, 3 times 4. This simply means we have 3 units of 4, as noted here, which is the same as 3 times 4 equals 12. So if you wanted to multiply 3 times 12, you would have 3 units of 12. Your final answer, 36. Multiply numbers to get an area in square footage, denoted SF. Arrange the above boxes side by side. Here we still have 3 times 12 gives you 36. This works for any area. 12 times 10, we have 10 across here, 12 across there, and you get an answer of 120 square feet. Here we have the same 12 foot by 10 foot, but we've taken this 4 by 4 area out. The way to solve for this is break it down into these 2 areas here. Area 1 being 8 by 10 and area 2 being 4 by 6. And when you add them together, you get 104 square feet. Or you can take the whole 120 square feet, subtract the 4 by 4 out, and you get the same answer, 104 square feet. 2 ways to get at the same answer. As we go through this training program, we're going to be stopping periodically to test your knowledge. So here, let's multiply the following equations, and the answer should be in square feet. Pause the video now, and please note that it's okay to use a calculator. When you complete the work, restart the video. Okay, let's review the answers. 13 times 50 equals 650 square feet. And please note that now we're working in feet, the answer should be in square feet. 75 times 120 equals 9,000 square feet. 120 times 324 equals 38,880 square feet. 80 feet by 240 feet equals 19,200 square feet. 1,050 times 750 feet, 6 inches, equals 788,025 square feet. You have to note here, we had to convert the 6 inches into decimal feet. And we'll be talking about that in the near future. Let's now talk about division. Division, in a way, is the opposite of multiplication. We are taking larger numbers and breaking them down into smaller parts. A simple example is 6 divided by 2 equals 3. Here we have 2 parts of 3. So let's look at 36 square feet. That is 3 units of 12 equals 36 square feet. It can also be written as 36 divided by 3 equals 12 square feet. Looking down here, you see 3 units of 12 equals 36. So 36 divided by 3 equals these 12 square foot of smaller parts. We use division in construction to divide large areas of floors, walls, building quantities down into smaller components. So back to test your knowledge, divide the following equations. The answer should be in square feet. Please pause the video now and do the work. Remember, it's okay to use your calculator, and when you're complete, restart the video. To review the answers, we have 50 square feet divided by 10 gives you 5 square feet. 120 square feet divided by 2 equals 60 square feet. 18,000 square feet divided by 4 equals 4,500 square feet. 19,200 square feet divided by 10,000 equals 1.92 square feet. 390,000 divided by 8 equals 48,750 square feet. Now let's have some fun. Let's talk about decimal equivalences. We all are used to a fractional rule where we have feet and inches. Well, you can't just always add feet and inches together. So let's talk about, we have decimal inches, and we have, which is shown here, and we have decimal feet, which is shown over here. To get a decimal inch, you just simply divide the numerator by the denominator. An easy way to look at this would be 1 divided by 2 is 0.5, or 3/4 of an inch would be 3 divided by 4, which would get you 0.75. This list here is an example of all the decimal inches from fractions using starting at 1/16 all the way down to 15/16. Decimal feet is the same way. You just simply divide, in this particular case, everything by 12 inches. So 1 divided by 12 gives you 0.0833. 1 divided by 5 would get you 0.4167. And 12 divided by 12 would get you 1 decimal foot. To get decimal inches in decimal feet, take this set of numbers here, divide it by 12, and you will get this set of numbers here. You can add decimal feet to decimal feet, meaning you can take this set of numbers here and add it to this set of numbers over here. In your handout, you will find a chart of decimal equivalences. You can use that for a reference as you become comfortable dividing these things out on your calculator. Here are some examples. We have 3/8 from the chart, that equals 0.375. Take 0.375 divided by 12 and you get 0.03125 decimal feet. Next we have 1/2 inch plus 5/8 inch. 1/2 inch in decimal inches is 0.5 plus 0.625, all from the chart, gives you 1.125 inches in decimal inches. So take the 1.125 decimal inches, divide it by 12, and you would get 0.0267 decimal feet. And the next example, getting a little bit more complicated, let's take 10 foot 6.5 inches plus 13 foot 9.25 inches, and you would get 24 foot 3 3/4 inches. The 3 3/4 inches divided by 12 would be 0.3125, and the final answer would be 24.3125 decimal feet. Or simply from the charts, you get the 0.0625, which is the 3/4 divided by 12. You get the 0.25, which is 3 divided by 12, and you would get 0.3125, which is the same answer you have up here, extended on out over there. Now back to test your knowledge. Do the math and provide the answers in the appropriate decimal equivalences spaces below. Please pause the video now and do the work. Okay, let's get started on reviewing the answers. Some of these answers can be slightly more or less depending on how you convert the decimal equivalences of inches to feet. In this test your knowledge exercise, we took everything to 4 decimals and rounded it up or down. Okay, 1/4 inch in decimal inches equals 0.25. Divide it by 12 and you get 0.0208 decimal feet. Number 2, 3/4 inch plus 1/8 inch equals 7/8 of an inch, and in decimal inches that is 0.875. Divide that by 12 and you get 0.0729 decimal feet. Number 3, first we have to add 3 foot 5½ inches plus 12 foot 7 7/8 of an inch, and that equals 16 foot 1 3/8 of an inch. And then what I did up here is I took 3 foot plus the 5½, divided the 5½ by 12, and I came up with 3.4583 decimal feet. I took the 12 plus the 7.875, which is 7/8 in decimal inches, divide that by 12, and I came up with 12.6563. And when you add the two of them together, you get 16.1146 feet. Number 4, again, add the 108 foot 4 inches plus, in this case, minus 1 foot 6 3/8 inch gives you 106 feet 9 5/8 inches. Again, I took the 108, which is 4 inches divided by 12, gave me 108.3333 feet. The 1 plus the 6 3/8 here gives you 6.375. Divide that by 12 equals 1.5313. When you do the subtraction, you get 106.802 feet. Number 5 is a multiplication. We're taking 1,010 feet 8 inches times 440 feet 9 inches, and you have to convert that into this 8 into decimal feet, which is 0.66667, and this the 9 inches into decimal feet, which is 0.75. And when you multiply them together, you get 445,451.3480 square feet. Number 6, we're taking 600 feet 4½ inches times 120 10 1/4 inches, and when you convert the 4½ you get 0.375. When you convert the 10 1/4 you get 8541. Multiply this entire thing together, you get 72,557.7803 square feet. Now let's talk about cubic measurement. We would all agree 1 foot times 1 foot equals 1 square foot. So it would be, if we add the third dimension by 1 foot, that would equal 1 cubic foot. expressed 1 CF. So with that concept in mind, take that 12 by 10 area, make it a foot thick, and you would have 120 square feet. Multiply that times 1 foot thick, and you get 120 cubic feet expressed 120 CF. Note that it's the same numerical value. What changed between the SF and the CF is the type of measurement. We went from square feet to cubic feet. So, how would you find the cubic volume measurement of 10 by 12 by 6 inches thick concrete slab? Well, you would get the same 120 square foot, 12 by 10, but now we're going to go 6 inches thick. Well, first you have to convert the 6 inches to a decimal foot, which is 6 divided by 12 equals 0.5. So 120 square foot times 0.5 gives you 60 cubic feet. Now let's convert cubic feet into cubic yards, which, as we all know, is how concrete is ordered. What is a cubic yard? A cubic yard is 3 feet times 3 feet times 3 feet equals 27 cubic feet. So to convert 60 cubic feet into cubic yards, you would divide by 27 cubic feet equals 2.22 cubic yards. Okay, we're back to testing your knowledge, and take a moment and calculate the following volume of concrete for the areas below. Answers should be in cubic feet. Pause the video now and do the work. Don't forget to convert to decimal feet, and remember, you can use your calculator. When complete, turn the video back on and we'll go over the answers. Okay, let's take a moment and review the answers. Number 1, 550 times 10 times 6 inches thick. The way you get the answer is 550 times 10 gives you 5,500. Take the 6, divide by 12, you get 0.5, multiply 5,500 times 0.5, and you get 2750 cubic feet. Also note, some of these answers can be slightly more or less depending on how you convert the decimal equivalences of inches into feet. Number 2, 120 times 60 gives you 7,200 square feet times 4 inches thick. Take the 4 divided by 12 gives you 0.333. Multiply 7,200 square feet times 0.333 feet, and you get 2398 cubic feet. Number 3, 18,000 square feet times 5 inches. Well, start with taking the 5 divided by 12 gives you 0.4167. Multiply it times 18,000 square feet, and you get 7,501 cubic feet. Number 4, 180 times 1,050 feet times 16 inches thick. Okay, what do we got to do here? Well, take the 180 times 1,050, and you get 189,000 square feet. Take the 16 divided by 12, and you get 1.333 decimal feet. Multiply that times the 189,000 square feet, and you get 252,937 cubic feet. Number 5. We're going to take 390,000 square feet times 8 inches thick. And the first thing you need to do is convert the 8 divided by 12 gives you 0.6667, and then multiply that 0.6667 times 390,000 square feet, and your answer will be 260,013 cubic feet. And number 6, which we're going to convert number 5 into cubic yards. So we're taking this 260 and divide it by 27 cubic feet, you get 9,630 cubic yards. And just to note, when you probably do it in your calculator, we rounded it down because you don't buy portions of a cubic yard. Now we're going to continue to test your knowledge. Find the area and the cubic yards of the following slab layouts. And question number 5 will be, using the slab plan below, this one here, find the total area of the slab, the total cubic yards in the slab, and find the area for each pour 1, 2, and 3, which is denoted 1, 2, and 3. Please pause the video here and do the work. Number 1, we have an area that is 136 times 205, and that's pretty easy. You just multiply that out and you get 27,880 square feet. Take the square footage times the 4 inches thick, and the decimal equivalence is 0.333 feet. And when you multiply that out, you get 9284 cubic feet. When you divide it by 27 cubic feet, you get 344 cubic yards. Number 2, a little bit more challenging. You've got to break this down into area 1 and area 2. And you could have done it area 1 and area 2, a variety of different ways, but the way I'm showing it to you is area 1 and 2. Area 1 is 20,500 square feet. Area 2 is 3,960 square feet, giving you a total square footage of 24,460 square foot. Multiply that times the 5-inch thick concrete slab, decimal equivalence being 4166. And remember, how we got that was 5 divided by 12. And then multiply that times the 24,460 square feet, and you get 10,190 cubic feet. Take that divided by 27 cubic feet per cubic yard, and you get 377 cubic yards. Number 3. Number 3, we had to divide it into, I call it area 1 and area 2. Note area 1, the 70 by 36 is the same here and here. So you can take area 1 times 2, which is what we did. We got 2,520 square feet times 2 gives you 5,040 square feet. You've got this area here, area 2, 49,200 square feet, get a total square footage of 54,240 square feet. Now you might be wondering, how did I get the distance for this area 2? We have 200 lineal feet that goes from here all the way up to there, minus this 36 lineal feet, and that gives you 164 lineal feet times the 300. When you multiply that out, you get to 49,200 square feet. To get the concrete quantity, you take it times the 6-inch slab. The decimal equivalence for a 6-inch slab in decimal feet is 0.5, which gives you 27,120 cubic feet, divided by 27 cubic feet per cubic yard, and you get 1,004 cubic yards. Number 4. Number 4, we divided into three areas. We have area 1, 2, and 3. And the answers for each one of those is 2,520 square feet, 10,000 square feet, and 49,200 square feet. Same concept we had above, except over here we made this area bigger down there, so it's obviously it is its own area now. The concrete, total concrete is 61,720 square feet. Multiply that times a 6 3/4 inch slab. Decimal equivalence of 6 3/4 is 0.5625 feet, which gives you 34,717.5 cubic feet divided by 27 cubic feet equals 1,186 cubic yards. I hope all that made sense to you. If it didn't, take a moment, rewind the video, and go through it step by step as I'd explained it, and see if that doesn't make more sense the second time. Number 5. The total square footage of the slab is 33,800 square feet. Pour number 1, 16,200. Pour number 2, 14,400. And pour number 3, 3,200 square feet. The total cubic yards in the slab is 626 cubic yards. Some of the math that might be explained here is you had to add some of these areas together. This 40 foot plus 40 foot plus 40 foot plus this 15 foot gives you the 135 lineal feet. Then across the bottom you've got 40 feet, 40 feet, 40 feet, gives you 120 lineal feet. So area 1 would have been 135 feet times 120 lineal feet to get this particular square footage up here. All right, let's discuss target and feedback. That's the name of the program. Where did target and feedback come from? Well, it came from the early days in Baker Concrete Construction. Dan Baker had a target every day for these guys to complete. Had to get a certain thing done. They had so many man hours. And at the end of each day and at the end of each week, each one of these team leaders got feedback from Dan on what was completed and did they meet their man-hour requirements. Today, the estimating team at Baker still uses man-hours to estimate the work. These man-hours are broken down into scope items in areas of work such as subgrade preparation, form slab edges, place finish concrete, build set strip wall forms, and of course many other work item tasks. The word target represents the man hours estimated to complete a scope of work or work item. The word feedback is what we completed today or so far on the job. And for this training session, we will concentrate mostly on what did we do today. So, if target is the man hours estimated for a scope or a work item, let's assume we have a slab that is 160 feet by 320 feet and is 5 inches thick. It would give you a total square footage of 51,200 square feet. And notice here, I've written this a little differently. I wrote it in FT-square. That also means square feet. The estimating team has assigned us 308 finishing hours and 160 labor hours and is based on 4 12,800 square foot placements. We have 160 man hours, 4 pours, so you divide 160 by 4 and you get 40 man hours per pour. If you break that down into an 8-hour labor day, that gives you 5 labors for each pour. The finishers have 308 man hours divided by 4 pours, gets you 77 man hours per pour. If we use 77 divided by 8, we get 9 finishers for 8 hours, or we could look at it as 7 finishers with 2 hours of overtime. And we'll talk about overtime here in a little bit, just in case some people don't understand it. So the target is 7 finishers for 8 hours with maximum of 2 hours overtime, and the laborers is 5 hours, or 5 laborers with 8 hours. Okay, what actually happened on pour number 1 was we had 7 finishers for 10 hours, which was the budget, but we had 5 laborers for 8 hours with 1 hour of overtime, which caused a man hours of 124.5. And remember, our budget was 117, which caused us to be over by 7.5 man hours. Pour number 2. Remember, the target is 117 man hours, and what we actually did is 7 finishers with 10 hours, including 2 hours of overtime, 5 laborers with 8 hours, and that gave us 117 man hours, which means we met the budget. And if you look back up here on our chart, for the second pour, we didn't go over or under, and we still have a plus of 7.5 man hours over the budget. So the team decided, let's try combining pours 3 and 4 together, and that gave them 10 finishers for 12 hours and 7 laborers for 10 hours, a total maximum of 217 man hours. And so if we put 217 man hours up here, we were under by 17 man hours and under by 9.5 man hours here. So if we look at the feedback for the job, we've got 458.5 man hours, and we were under 9.5 man hours for the whole project. The target was 468 man hours. The savings was 9.5 man hours. So the feedback is we beat the budget. Let's test your knowledge. Using the slab plan from an earlier exercise, let's look at the man hours estimated to place and finish this slab. We have a total slab area of 33,800 square feet. To finish all 3 placements, the target is 420 man hours. Use the following pages to calculate the man hours spent on each pour and fill in the chart for over, under, like done in previous example exercises. Using this chart right here, multiply out 9 finishers times 8 hours times 8 hours or 4 hours of overtime for 1 day, and you would put the man hour result right here. Let's take a minute and look at how to calculate man hours. We have 9 finishers times 8 hours of time and 4 hours of overtime. So we take 9 times 8 gives you 72 hours. Then you have 9 finishers with 4 hours of overtime. Each overtime hour is worth 1.5 hours. So 4 times 1.5 equals 6. So it's 9 times 6 gives you 54 man hours, total of 126 man hours that you would place in this box right here. Pause the video now and do the work. Let's review. Line 1, 126 man hours. For the laborers, we have 66.5 man hours. On pour 2, we have, for the finishers, 100 man hours. For the laborers, 57 man hours. On pour 3, we have 4 man hours for the finishers, or 32 man hours for the finishers, and 32 man hours for the laborers. And in this case, because all 3 pours are different, it would be hard to keep track of the over and under for each pour. You would have to look at it by the total spent to date versus the total allowed for the job. So if we look at pour number 1, we add these 2 numbers together and we get 127.5 man hours. We had 420 man hours minus the 126 and the 66.5 gives you that 227.5 man hours left. For pour 2, we end up with 70.5 man hours, and for point 3, or pour 3, we have plus, we're still under by 6.5 man hours. So the feedback is we beat the target. All right, now let's do another test your knowledge activity here. Find the total square footage, find the area for each pour number 1, pour 2, and pour 3. Pours versus pour 1, pour 2, and pour 3. We have a 5-inch thick slab, so calculate the total cubic yards. Pause the video now and do the work. I'm not going to go through all the math, but the total slab area placement was 43,400. Area 1, 17,000 square feet. Area 2, 14,400 square feet. Area 3, 12,000 square feet. And the total cubic yards was 670 cubic yards. Continuing on with some test your knowledge, we're going to look at the placements required to get this particular job done. The target is 382 man hours, and due to a bad day's first placement, we used 172 man hours. Your job here is to balance out the last 2 placements without using any extra man hours. Pause the video now and do the work. Note that pour number 1 used 8 finishers, 8 hours of straight time, 5 hours of overtime, that's where they lost it, and the finisher used 6 laborers for 8 hours, a total of 172 man hours. That gave them 210 man hours left. Your job is to figure out pour 2 and pour 3 without using any more than 210 man hours. Note, there could be more than one answer. Here is suggestion manpower number 1. Remember, we had 172 man hours that we spent on the first pour, gave us 210 man hours left. That was calculated by taking the 382 minus the 124 plus the 48, gives you 210. Pour number 2, we took 7 finishers, 8 hours, 2 hours of overtime, gives you 77 man hours, 5 laborers, 7 hours of straight time, and gives you 35 hours of man hours. That's 112 total man hours to get the pour done, and you have 98 man hours left over. In pour number 3, 6 finishers, 8 hours, 5 laborers, 6 hours, you get 48, 30, 78 total man hours, and 20 man hours left over. The plus sign here indicates that you are under 20 man hours. Now, I also understand that it's unreasonable to assume that a finisher's only going to get 7 hours for the day. You'd probably pay him for 8, and that, of course, would affect your amount of man hours you had left over here. I'm kind of assuming there might have been some other job task that you may have been able to assign him to for the remainder hour of the day. Let's look at an additional manpower, configuration number 2, and that would be to place pour 2 and 3 together, a total of 26,400 square feet. We used 12 finishers for 8 hours, 96 man hours, 10 laborers for 8 hours, 80 man hours. 8 of those finishers worked an additional 4 hours of overtime, and 4 of those laborers worked an additional 4 hours of overtime. They gave you 48 and 24 man hours, a total of 72 man hours, and ultimately we ended up with a minus 38 man hours, meaning that we exceeded our budget by 38 man hours. Let's review. Multiplication. Remember, 3 times 12 is no more than 3 units of 12 that equals 36. When measuring areas that are rectangular but have little blockouts, break them down into area 1 and area 2 and then add them together. Division is nothing more than taking a larger number and breaking it down into smaller parts. So if you had 36 square feet, you divide it by 3, you would have 12 square feet. Cubic measurement is nothing more than adding the third dimension. We have 1 foot times 1 foot gives you 1 square foot. Make it a foot thick, and now we have 1 cubic foot. To convert cubic foot into cubic yards, we divide by 27 cubic foot. That's how many cubic feet are in a cubic yard. So here in this example, we had 60 cubic feet divided by 27 cubic feet, and we end up with 2.22 cubic yards. Remember, target and feedback is why we're here today. Target represents the man-hours estimated to complete a scope of work or a work item, and feedback is what has been completed today or so far on the job. As seen here in this example, we have 382 man-hours to complete these 3 pours. The feedback is what we spend each day. So these are these hours added up. We had 172 man-hours, 112 man-hours, and 78 man-hours on pour number 3. The feedback would be we did it for 162 man-hours and we had 382 man-hours to complete the project. We are going to do some more test your knowledge, and we're going to do it in 2 phases. Phase 1 will be reviewing some of the math work. So do the following equations and fill in the blanks here. And on question number 18, find the slab areas for pour number 1, 2, and 3, and the cubic yards to the nearest cubic yard. And when we're complete with this, we will review it, and then we will use the slab area placement to do a final target and feedback exercise. Pause the video now and do the work. Let's review the first part of the math here. I am not going to show all the math. If you're confused, rewind the video and go back to those math sections and watch how I worked all those problems out. So the answer to question number 1, 1,200 square feet. Question number 2, 10,625 square feet. Question number 3, 64,500 square feet. Question number 4, 24,180 square feet. Number 5, 1,013,253.75 square feet. Number 6, 7.5 square feet. Number 8, 3 square feet. Okay, number 7, 3 square feet. Number 8, 6,750 square feet. Number 9, 32.52 square feet. Number 10, 93,750 square feet. Number 11, 4,500 cubic feet. Number 12, 6,639.33 cubic feet. Number 13, 500,000 cubic feet. Number 14, 1 million cubic feet. Number 15, 2,542,916.66 cubic feet. Number 16, 37,037 cubic yards. Number 17, 94,182 cubic yards. Number 18, the slab placements 1, 2, and 3 Number 1 is 17,000 square feet. Number 2 is 20,800 square feet. Number 3 is 24,000 square feet, a total of 61,800 square feet, and gave you 1,770 cubic yards. Number 19. Use the previous slab 3 placement plan layout to calculate the manpower for the final 2 placements based on the manpower usage of the first placement. So we have 3 placements. The target is 590 man hours. The first placement used 174 man hours. Your job is to plan out the last 2 placements and either balance out or save man hours. Now you can use the downloadable Excel man-hour projection sheet to manage your hours. You may have to purchase it. It works on both Microsoft Excel and Apple Numbers on most smartphones and iPads. After the first pour, there is 416 man hours left to complete the job at or under budget. Pause the video now and do the work. One possible answer on pour number 2 is to use 9 finishers for 8 hours with 5 hours of overtime and 6 laborers for 8 hours with 1 hour of overtime, and you will have spent 187.5 man hours, gives you 228.5 man hours left over. And on pour number 3, 10 finishers, 8 hours with 6 hours of overtime and 7 laborers for 8 hours with 2 hours of overtime, give you a total of 226 man hours with 2.5 man hours left over, under budget. And also, just please note, this is one possible answer. Next, let's look at additional ways to look at man hours. First, we can look at the portion of a man hour as it relates to each square foot of work. This is done by dividing man hours, for instance, 590, by the square footage, 61,800, and the budget would be 0.00955 man hours per square foot. This information is useful at each placement so you can see whether you are under the budget or over the budget. This will assist in projecting whether the job is on track or not. You can see the first pour is over some and placements 2 and 3 are under. If this number here is higher than the budget, then the job is underproducing as seen in the first pour. If this number is lower than the budget, then the job is making money as seen in pour number 2 and pour number 3. Ultimately, the combined pours and the man hours per square foot are under budget. And now an iteration of that, and it's probably easier for you to understand, is looking at square foot per man hour. This is done by dividing the project square footage, 61,800 square feet, by the man hours, 590 man hours, which equals 104.7 square foot per man hour. As we saw in the other way on the first pour, we only got 97.7 square foot per man hour. We are over the budget, meaning we were supposed to complete 104.7 square foot per man hour and only did the 97.7 square foot per man hour. If we continue on this path, we'll be over the man hour budget to complete this scope of work. If this number is lower, we are underproducing, and when this number is higher, we are making money, as seen in pours 2 and 3, and ultimately combined, we have 105.2 man hours per square foot. We are under budget. Please go to Baker University training site and download the target and feedback Microsoft Excel or Apple Numbers spreadsheet. These will aid in your tracking the work completed, the man hours, and the man hours left to finish the job tasks. Here is the link. Future target and feedback training will be on foundation forms, wall forms, and placing concrete. This concludes the training. My name is Dan Dorfmiller, and if you would like to contact me, you can contact me at dorf@dorfmiller.us.